So, oh, got to have my favorite student, Lucas. Who's my favorite student? Good old. Oh, added an extra N. Ann Cirque. So, an airplane turns a complete horizontal circle. Mentally, I underlined that. I was trying to visualize in 2 minutes, and then right away, I came to a stop. Paul, the first thing I said is, nice try, Dueck, 120 seconds. If the plane's speed is 170 meters per second, what's the radius of the circle? I said, you know what? They gave me centripetal speed. I think I can use centripetal speed is 2 pi r over the period. I did a quick check. Yeah, they gave me speed. They gave me the period. I just got to get the r by itself. So r is going to be v times t divided by 2 pi. It's going to be v 170 times t 120 divided by 2 pi. I got my trusty calculator out. 170 times 120, close bracket, divided by bracket, 2 pi. And I got a pretty big answer, which made me nervous at first because that's almost 3 kilometers. No, wait a minute. I've watched airplanes slowly turn. It would probably take a big circle of a few kilometers. Otherwise, you'd be pulling too many G's. So I'm okay with that. I'm going to write it as 3,250. Is that right? I think, yes. Okay. I would probably give you half mark if I saw that, half mark for that, half mark for the numbers, and a half mark for the answer. What is the centripetal acceleration of the airplane? I could go v squared over r since I have v sitting on my calculator, and if I was confident that I had done this question right, I would go, oh no, they gave me v, didn't they? You know what? Yeah, I could just do that. Well, no matter what, I have to use the radius. I could go v squared over r, or I could go 4 pi squared r over t squared. I chose to go v squared over r. So it was going to be 170 squared over, and I just wrote my answer button is what I'm going to do. 170 squared divided by answer button. And I got 8.9. Yeah, they're pulling a little less than a G, which means would they feel heavier or lighter? They feel a little bit lighter. You would feel a little bit like you were falling, a little bit. And they're probably losing a bit of altitude. For 2 marks, 1 mark for the equation, 1 mark for the numbers, half mark for the numbers, half mark for the answer. If you got A wrong, but you successfully went 170 squared divided by your answer, or you went 4 pi squared times your answer divided by 120 squared, I'd give you 2 out of 2. Nicole, what's number 2 asking me to find? What force? What for? You know what? This is no free body diagram. I can jump straight to FC equals, don't forget the M, AC. Which version of AC am I going to use? I see a period, so it's going to be M4 pi squared R over T squared. It's going to be 12 kilograms, so bowling ball-ish, times 4 pi squared. R is 6 meters divided by 0.2. Don't forget the squared. I got a huge answer here, which at first made me nervous. 12 times 4 pi squared times 6 divided by 0.2 squared. Yeah, did you get is it 71,000? And I'll go 100 newtons. I went, wow, that's really, really big. But then, Reed, I thought about it. First of all, 12 kilograms, about a bowling ball. 6 meters. Reed, there's roughly 6 meters between you and I, give or take. What's the period? 0.2 seconds. That means we're spinning a bowling ball on the end of a rope 6 meters long 5 times a second. That thing would be a blur. Yeah, that's going to take a huge force to do that. You would need heavy machinery to do that. So when I got that answer, at first I was nervous, and then when I zoomed out and actually looked at the values, I went, oh yeah, like standing in front of that bowling ball, it would kill you and pulverize you. You would not want to get hit by that. Number 3. Ooh, Matt, what do they want me to find in number 3? Okay. I don't need to worry about free body diagram. Am I going to use the one with the V in it, or am I going to use the one with the T in it? Yeah, it's going to be V squared over R. The only sneaky thing, I crossed out the 25 centimeters, and I said, nice try, Mr. Dueck, 0.25 meters. And in fact, it's going to be 5 squared over 0.25. Is it 100? Even, right? Yeah. This belt's pulling about 10 Gs. It would have to be a fairly strong belt. Ooh, Ferris wheel. They want the force the bench exerts at the top. So I did kind of a little arc to help me visualize the top. And in fact, I drew a little person just sitting like that so I could visualize which way their head was, because the normal force is always going to be in the, when you're sitting, in the direction your head is pointing. So I said, what are the forces acting on this? Get the obvious one, mg. Why did I draw gravity so big? Because what path are we tracing out? Where do I know the winning force is going to be pointing? So I made it self-obvious because now I can draw the normal force shorter. It says, what's the force the bench exerts at the top of the Ferris wheel? There's my free body diagram. So it's going to look like this. Winner minus loser equals MA. You know what? I was a little sneaky. I didn't write AC. I saw that they gave me 25 seconds, and so, Leo, I went straight to M4 pi squared R over T squared. I want to get the normal force by itself. I'm going to do a swappy dance. I'm going to get mg minus m4 pi squared R over T squared. And then, Lucas, if you don't mind, I'm going to put the normal force right there because that's where we're used to seeing things by itself. Do the m's cancel here? Isn't there an m in everything? Not in the normal force. This is why I told you, actually, the heavier you are, the more intense a ride is. You might age out of some rides as you get older. Rides that you enjoyed as a kid, you might find when you hit your middle age and you start to gain some weight, uh-oh, I don't like this ride anymore. So far, I'm going strong, but every year I wonder, will I age out of some of my favorite rides? I hope not. M. Ooh, they didn't give me the mass. They gave me the weight. Well, you know what? That's mg. Minus. Now, I have 4 pi squared. I have r, 9, and I have 25 squared. How can I put m here? I was really lazy. I said, you know what? M is going to be 637 divided by 9.8. I just did it in one step. You could have somewhere in the margin gone m equals 637 divided by 9.8, 637 divided by 9.8. Did I get, 65 kilograms. And so you could have also just done that somewhere off in the margin. But you've known me enough, Leo, to know if I can do it in one step on my calculator, I'm doing it one step on my calculator. So 637 minus 637 times 4 pi squared times 9 divided by bracket 9.8 times 25. Don't forget the squared. And I got 600, almost even. No? Yes? Okay. In terms of part marks, I would probably go something like this. 1 mark if I saw that, 1 mark for that, half mark for the numbers, and a half mark for the answer. Ooh, what's the force the bench exerts on the person at the bottom of the Ferris wheel? Again, Raisa, I just did a quick sketch. And I said, okay, there's the person sitting. What are the forces acting on them? Get the obvious one, gravity. You'll notice this time I didn't draw it as long because I know the winning force is in this direction. It's going to be the normal force. My equation now is going to be normal force minus mg equals m4 pi squared r over t squared. How would I get the normal force by itself? I would plus the mg over. It's going to be normal force equals mg plus m4 pi squared r over t squared. Now, I was clever. I noticed, Nicole, that this expression is exactly the same as this expression, but instead of a minus sign, it's a plus sign. And so if I was doing this as a homework question, I would have just said, you know what, I'm going to backspace on my calculator. I'm pretty sure that's the answer. This is a quiz, and so I'm going to show my work. But if I was doing this on my homework, I would just probably have tried to do all of it without writing anything down. Ha ha. It's going to be 637 plus, this time I'll just write 65 times 4 pi squared. R was 9 all over. What was the period, Mr. Dueck? 25. Don't forget the square. And I ended up with 674. Is that right? Not that big a difference between the original at-rest 637 newtons. Yeah, Ferris wheels are tame rides. I made these numbers much more reasonable. But now we get to ride a roller coaster. Like I told you last day, your test is definitely going to have a gravitron, it's going to have a roller coaster loop, and it's going to have a Ferris wheel. Now, this roller coaster loop, I didn't bother trying to make it safe. We noticed that in real life, if you're in a circular roller coaster, you're pulling at least 6 Gs. You might be pulling more here. I wasn't interested in making one that was fun to go on health-wise. It would just be fun to go on adrenaline rush-wise. At the top, it experiences a normal force 4.5 times their weight. How fast is it traveling? Leo, what might this be a good job for? How do I know? We're tracing out a circle. Oh, and also how fast? I'm pretty sure I'm going to use mv squared over r. What are the forces acting at the top? Get the obvious one. I said definitely gravity down. And then I also said normal force, but which way is the normal force here? Which way is my head pointing? Downwards. So the normal force is going to be downwards. Who's winning? They both are. My equation is going to look like this. mg plus the normal force equals mv squared over r. Now, this wants me to find v. I could get the v by itself, but I noticed I can do some simplifying first, because if the mg drops down like a domino, they said the normal force is 4.5 times their weight. What's their weight mathematically in physics? Whenever I say weight, which force am I talking about? No, I'm never talking about weight is mg. By the way, so apparent weight, the weight that you feel, that's the normal force. But your actual weight, mg. So it's going to be 4.5 mgs. That equals mv squared over r. And I noticed these are like terms. 1 mg plus 4.5 mgs. I said I can simplify this to 5.5 mgs. That equals mv squared over r. So will little kids and grown-ups all feel 4.5 times their weight? Why? Okay. Oh, and you know what? How would I move the r over? Am I going to get my old friend, the square root of GR, and some other stuff? I've probably done this right. V is going to be the square root of 5.5 GR. It's going to be the square root of 5.5 times 9.8 times 11. No idea what the answer is. 5.5 times 9.8 times 11 square root. 24.3? Yeah. If you got that, I would give you 4 out of 4. Otherwise, 1, 2, 3, 4, 5, 6. I would probably go something like this. 1 mark if I saw that. 1 mark if I saw that. Half mark for that. Half mark for that. Half mark for the numbers. And a half mark for the answer. After the first loop, the riders hit a second loop. At the top of the second loop, the rider is traveling 16 meters per second and they feel a normal force of twice their weight. What's the radius of the second loop? I cheated a bit here, Raisa. I said, I'm pretty sure since we're at the top of the second loop, the free body diagram is identical. And then I said, which means I think the equation is identical. I think I can take this first line, mg plus fn equals mv squared over r, and I can just recreate it right here. mg plus fn equals mv squared over r. In fact, I think I can make a similar argument. The normal force is twice their weight. Matt, I think I can go mg plus 3mg equals mv squared over r. What's mg plus 3mg? I'm pretty sure 4 mg's. Yes? Twice, not 3. Wow. I was doing the math in my head already. Now we're going to get 3mg equals mv squared over r. Once again, little kids and grown-ups will feel the same sensations. But again, if you're heavier, if you have a bigger mass, the magnitude of the force that you feel will be much larger. This is why you can age out of rides. And that was more intense than I wanted. Oh, now we want to get the r by itself. I guess I'm going to times the r to the top and divide the 3g. I think r is going to be v squared over 3g. It's going to be v16 squared over 3 times 9.8. 8.71? Yep. I had some built-in error checks. I knew because the loop is smaller, you're not going to be going as fast, or are you going faster? How fast? Yeah, 24.3 at the top of this loop, 8.71 meters per second at the top of this loop. If you got that, 4 out of 4. Otherwise, again, I would go 1 mark for that, 1 mark for that, half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. Can you give yourself a score on this quiz out of, count 'em, 22, please? Any lawyering with me? Now is the time.